Question 5. So in this one, we have a 9 kilogram block. It's a hanging object. Okay, so that's the one that's hanging, is going to be 9 kilogram. It's on a frictionless pulley to a 5 kilogram block that is sliding on the flat table. So that's M1 is 5 kilogram. Okay. Taking the coefficient of kinetic friction, so that's mu. So mu is equal to 0.2. Okay. Find the tension that's in the string. Okay, so there'll be some tension there, obviously, because it's being pulled around. Okay, so this one gets a little bit trickier. It is question 5. So we need to find the tension that's in the string. So I'm going to do free body diagrams, just like I always do. I have 2 objects that are moving, so I need to go ahead and calculate those. I got to figure out quite what is going on with these ones. So my first free body diagram I'll just make out of mass 1. So a few things I need to look for in mass 1. All of the forces, we know that there's going to be an Fg, which is equal to mg, pulling that block straight down. The table is going to give us a normal force pointing back up. There's going to be some tension on that string, pulling that direction, okay, as it pulls. And then this one will also have some friction. Friction force is always mu Fn. Okay, so tension is the one that I'm looking for here. Let me go ahead and write out some equations for this. If I do my summing of the forces, what do I get? So is the box M1 accelerating in the x direction? Well, yes, it is. It's being pulled by this one, and it's going to have some acceleration. It's going to change its direction and be pulled that way. So we'll have an MA here for that. We'll have an MA. That MA has to be equal then to T for tension. Okay, that's our pulling force or our acting force. And there's going to be that friction force involved. So I'm going to minus the friction force, mu Fn. If I look at the y direction, are we accelerating in the y direction? Not on block 1, that's sliding along the table. So that's 0. So I know here that this is equal to the normal force, Fn, minus the gravitational force, mg. Okay. So what did that tell me? Well, again, I have this 0 here, so that tells me that the normal force is equal to the mass 1, which is 5, times the gravity, which is 9.8. Okay. If I plug that in, this is 49. 49 newtons for the normal force. Now what I want to find is tension, right? So I want to solve here for T. Well, if I add this mu Fn, being I know Fn now, to the other side, let me see what I can get. I'll have Ma, okay, so I know the mass. The mass is 5. The acceleration, though, I don't know. I know it's accelerating, but I don't think it's at g because it's being pulled with this and there's friction going on, so it's definitely not in free fall. So I'm just going to have to leave it as an A for right now. I know this is equal to T, tension, that's what I'm looking for, is tension. And then minus mu. All right, I have mu, that's 0.2, 0.2, times the normal force, and the normal force is 49. Okay, so I'm getting there. It's getting a little closer. 49 times 0.2 gives me 9.8. So let's see. Let me go ahead. Try and organize this up a little bit more. I'm going to solve for T by itself, so I'm going to move this to the other side so that I'll have something like T, for instance, here is equal to 5a plus 9.8. Okay, so that's what this comes to, is 9.8. Okay, and I've moved it to the other side. If you need some help with the math, rethink this or do more steps so that this makes okay sense to you. I'm just adding this bit to the other side, and then I just simply flip the equation around. So this is 9.8. So I've got this a in here that I don't know. I really would like to solve for t, but I can't do it, but that's okay. I have a whole second block. So hopefully that second block will give me some more information. So we'll start on that one. This is M2, and it has two forces. It has, of course, the force of gravity, which is mg, which is not the same as this because this block is heavier. And there's no normal force. The only force that's pulling up is tension. And there's no left and right force. So this one gets a little bit easier. I know Fx is absolutely nothing. It's not moving and there's nothing to add there, but it does give us a little bit more on the Fy. The Fy tells us that yes, it is accelerating. And I know from the picture that if this block is accelerating this way, this block must be accelerating downward. So I'm going to have a negative ma. Okay, I'm going to have a negative ma because that's a negative acceleration. I know that that is equal to t, which points up, and mg, which is down, so minus mg. Okay, let's start plugging in some stuff and see what I can figure out on this one. So first, let's see if this is equal to t. Let me take this mg and move it to the other side as well, and see what I can figure out with that. So I want to solve for t, so I'm going to do the same thing like I did here. I'm going to move mg to the other side, so we're going to have a negative m, in this case it's 9, times a minus 9 times 9.8. Okay, so that's just filling in the, oops, it's supposed to be a plus there. Added that to the other side. Okay. So I have another expression for t, okay, that involves this a, which I don't know, but I do know something about this a. If this block is accelerating this way, then that means that this block has to be accelerating with the same magnitude, just in a different direction. So I know that the a's on the two blocks have to be the same because they're connected. They would accelerate at the same speed. So the a's are the same, but I need to solve for t's. So this is what we call a set of equations. I have two equations, and I need to, with two unknowns. Two equations, two unknowns is solvable. Okay, that's fine. What we have to do is we need to eliminate the thing that we don't care about so we can solve for the thing that we do care about. So in this case, I want to solve for t. I don't care about a. The question didn't ask what a was, it asked what t was. So I want to eliminate a. So what I'm going to do is I'm going to solve one of these equations for a, and then I'll plug it into where a is. Okay? Then I'll only have t's, and I can solve for t. Okay? So that's what we'll do. We'll plug in for an a. So let's see. Why don't I go ahead? I'll rewrite this one here for a, and then I'll plug in a over here. So I'm going to rearrange this equation. So what I want to do then is I'll have t minus, and what is this 9 times 9.8? It's 88.2. So I'm going to have t minus 88.2. Okay, so if I minus that to the other side, that's equal to a negative 9a. So if I divide by a negative 9, this will tell me what a is. Okay, I apologize if my 9s look like a's. If I take that a and I plug that in over here, it's going to get a big equation, a little nasty, but it's going to get there. We'll have t is equal to 5. Now a is this. T minus 88.2 divided by a negative 9. And then you can't forget the rest of it, plus 9.8. Okay. Now I've got an equation that only has t's in it. I just have to get the t's on the same side. Okay, so now I just need to rewrite this so that it is t equal 5t over 9. Oh, sorry, over negative 9. Okay, minus, and then I'm going to incorporate the 5 into that, so I'll have 5 times 88.2 over negative 9. Okay, so all I've done here is I've just taken the 5 and I have distributed it and made it into 2 fractions. Now that is plus 9.8. Okay, so it's getting a little bit messy, but it is problem 5. We should be getting to the harder ones now. I need to get this over to the other side. So what I'm going to do is, right now it's negative 5/9 t. I'm going to add 5/9 t. Okay, so if I add 5/9 to 1, what do I get? Well, I get 14/9, right? 9/9 plus 5/9 gives me 14/9, and I'm adding it. So I'm going to have 14/9 times t is equal to minusing a negative. So I'm going to end up with 5 times 88.2 over 9 plus 9.8. Okay. We're getting there. This on this side now is just a number. Okay, we can take 5 times 88.2, divide by 9, and then add a 9.8 to it. And we get that 14/9 t is equal to 58.8. All right, now to get t by itself, all we have to do is just multiply this to the other side. So we multiply by 9 and then divide by 14. So this will give us t. Okay, so I'm going to go ahead and do that. I got 58.8. I want to multiply by 9. That can be 529.2. And then we're going to divide it by 14. And if we do that, we get 37.8 newtons. This is our answer. Barely squeaked it in on that paper, but that's exactly what we have up here, 37.8. So, simple problem it looks like, but it is a long one. If you understand it, though, it makes a lot of sense. You have 2 of these, so you're just going to have 2 free body diagrams, which gives you 2 equations. You have to use those 2 equations to simplify down and solve for the common variable, which is tension and acceleration. Both of those are the same because they're attached to the same blocks, right, by the same thing. Okay, hopefully that worked out okay. Hopefully you do okay on it.